So this is an introduction class of Hadoop, or you can say an overview of Hadoop. So I will start with the agenda for this demo class. So the agenda for today is what is Hadoop, why do we need Hadoop, how Hadoop works, HDFS architecture, what is MapReduce, Hadoop cluster, Hadoop processes, topology of a Hadoop cluster, distinction of Hadoop framework. Distinction means how Hadoop framework is different from other framework. And last but not the least is prerequisites to learn Hadoop. You may not have heard about these words like HDFS or MapReduce. These may be new words for you, but we will be explaining each and everything one by one. So I would like to start with the first one, that is what is Hadoop. So let's start with the first one. So what is Hadoop? So Hadoop is an open source framework. In the straight, I think someone has arrived. Hello Nutan, can you hear me?
Yeah, I'm here.
Okay. Lalita, can you hear me?
Yes.
Okay. I'm on the first slide only that I was talking about the agenda. So I would request everyone to please mute because there is a little disturbance in the call. In case you are having any doubt, you can unmute yourself and you can ask me. Is that fine? Yeah. Yeah, that's it's better now. So it is an overview of Hadoop, or you can say that it's an introduction class of Hadoop. So I would like to make this as interactive session. Whenever you are having any doubt, please stop me over there and you can ask your doubt. So let's start with agenda. So the agenda for today's class is what is Hadoop, why do we need that, how Hadoop works, then HDFS architecture, what is MapReduce. I will explain more about HDFS and MapReduce in the coming slides. Then what is Hadoop cluster, what are different Hadoop processes, topology of a Hadoop cluster, distinction of Hadoop framework, and last but not the least is prerequisites to learn Hadoop. What are the software and hardware requirement if you want to go for this Hadoop training? And distinction means how a Hadoop framework is different from other framework. So we'll start with the first one. What is Hadoop? First of all, it is an open source framework. Open source means this is free of cost available over internet. This has been developed by Apache. So you can go to Apache website. You can download Hadoop from Apache website and you can use it. You can use it for your own purpose or you can use it for your enterprise purpose as well. So that is free of cost available. The next is it is used for distributed processing of large data set. So before we go much deeper in the technical part, let me give you some layman examples so that you can understand the concept of Hadoop in more easier way. So suppose there is a school and in school there is a principal and there are 10 teachers as well. Now there is a task. The task is of checking 1000 answer sheet of students. Now the principal has two options. Either the principal can start checking those 1000 answer sheet by himself. He may be qualified enough to do the task. But the thing is, if a single person will try to do a big task, he will take a lot of time. Instead of that, if the principal can distribute the task among his 10 teachers, the same task can be completed in less amount of time, because there is a simple mathematical concept. If there are more number of workers, the same task can be completed in less amount of time. So similarly, the same concept applies to Hadoop. Instead of doing a big complex processing on a single machine, that single machine may be capable of doing that, but it will be taking a lot of time as the data is very large. In that case, instead of doing the processing on a single machine, we can distribute the processing among multiple machines. So ultimately, we can complete our processing in less amount of time. So that was the example I had given to you. That is for make you understand the third line. That is, it is used for distributed processing of large data set. Distributed processing means whatever processing is required, we are not doing on a single machine. Instead, we are distributed the processing among multiple machines. And large data set means the data size is quite large. That's why we need to distribute the processing among multiple machines. So that was all about the meaning of third line. There is one more similarity between the school example and Hadoop. In school, principal is controlling the teachers, or you can say principal is giving instruction to the teacher to get some particular work done. Similarly, in Hadoop, we have multiple machines. Out of multiple machines, one machine is working as a master machine, and remaining all the machines are working as slave machines. So master machine is giving instruction to slave machines to do some particular work, and slave machines are the machines which are working for us. So that was all about the architecture of Hadoop. You can say the master slave architecture. So the next we have is, it works across cluster of computers using a simple programming model MapReduce. Cluster of computers means a set of multiple computers. This may be 5 computers, 10 computers, 50 computers, depending upon the requirement, which are connected to each other through some network, and using a simple programming model MapReduce. So MapReduce is a programming model, or you can say that MapReduce is a special type of Java program which is capable of executing on multiple machines. You know that a simple Java program can be executed only on a single machine, but as we are doing distributed processing, it means that we need something which can be executed on multiple machines at the same time, so that we can achieve the parallelism. So the thing we need is nothing but MapReduce only. MapReduce is a special type of Java program with a specialty that it can be executed on multiple machines at the same time. So friends, this was all about what is Hadoop in brief. And if you are having any doubt, you can ask me now. Otherwise, we can proceed to the next slide. So Vamsi, I think you have just joined. So if you are having any doubt on this one, this is first slide only. Vamsi, can you hear me? Okay, so let me proceed now. The next we have is, why do we need Hadoop? So before we go for any training, or before we want to learn anything, we must know, do we really need that? So let's see why Hadoop is required. So the first and the most important reason behind why do we need Hadoop is, data is growing faster. So data is growing faster because we are purchasing the products from online websites, we are using net banking, even banks are using online transactions. And apart from this daily task, we are also engaged in social networking, the Facebook, LinkedIn, or Twitter. So ultimately, whatever activity we are performing or internet, ultimately we are increasing the data size only. In old days, we were processing data in MB or GB, but nowadays and in the coming days, we need to process multi petabytes or multi terabytes of data. So as the data size is quite large, that cannot be handled on a single machine. That's why we are handling the data with the help of Hadoop. The next we have is the performance of traditional applications is decreasing. What does it mean? It means that when you are increasing the load in the traditional application, there will be decrease in performance. Suppose you are working in Oracle or MySQL, and suppose you are working with the data size 200 GB, and your traditional system may be giving you good performance. Now after 2 years, when your business has grown up and your data size has increased from 200 GB to 5 terabytes. In that case, if you are still using the same system and same hardware, then there will be decrease in performance because you have increased the load from 200 GB to 5 terabytes, but you are still using the same hardware. So this is the issue with the traditional system. But the same if I compare with Hadoop, if you will increase the load in Hadoop, there will not be decrease in performance. Why? Because the number of machines in a cluster is not constant. It means that when I started my business, when I was dealing with 200 GB of data, I may have a cluster of 5 machines only, and that was giving me good performance. When my business has grown up and my data size has increased from 200 GB to 5 terabytes, instead of 5 machines, I can set up a cluster of 20 machines. So as your data size is increasing, accordingly, you can increase the size of your Hadoop cluster. You can increase the number of machines in your Hadoop cluster. Ultimately, if the number of workers are increasing, the more data can also be processed in less amount of time. So that was about the number of machines in a cluster. Next we have is failure is expected rather than exceptional. It means that in hardware or in software, we cannot guarantee that system will not fail. That may fail at any time. So if we are doing the processing in traditional systems like Oracle or MySQL, and if your system crashed, in that case, whatever processing you had done, that is lost now. You have to reboot your system. You have to restart your Oracle server. After that, you will start your processing again. That will take a lot of time again. But as compared to Hadoop, in Hadoop, if 2 or 3 machines are down, it does not mean that your complete job will be failed. Let me compare with a school example. The principal had assigned a task of checking 1000 answer sheets to 10 teachers. If 2 teachers or 3 teachers are not feeling well, does it mean that the task of checking 1000 answer sheet will not be completed? No, it's not like that. The only thing is now the task will be completed with the help of remaining available 7 teachers or 8 teachers. So the only thing is they may take a little more time, but my task will be still completed with the remaining available teachers. So the same concept applies to Hadoop. In case 1 or 2 machines are down, we can still complete our job, complete our processing with the help of remaining available machines. So that was all about why do we need Hadoop. If you are having any doubt, you can ask me. Otherwise, we can proceed to the next one. Okay. So next is how Hadoop works. So our Hadoop consists of 2 things. One is processing. I was talking about processing, that there was big complex processing that could not be completed on a single machine, and that's why uh, we need multiple machine. We distributed the processing among multiple machine. The same problem may arise for storage as well. You can say that if there is a big file and I need to store that big file on any of the machine, but the file is too big to be stored on a single machine. So just like I distributed the processing among multiple machines, similarly I can also distribute the storage among multiple machines. So you can say that the first part which is dealing with the storage, is known as Hadoop Distributed File System. In short, it is known as HDFS. So this part is taking care of storage of large amount of data on your Hadoop cluster, and the second part, then MapReduce, or you can say processing, it takes care of processing of large amount of data on your Hadoop cluster. And as the name indicates, MapReduce is made up of two words. One is map, or you can say mapper, and another one is reduce, or you can say reducer. So this was very brief about the two parts of Hadoop: storage and processing, mapper and reducer. So we'll talk more about each part. So we'll start with the first one, the storage part, Hadoop Distributed File System, that is HDFS. So let's proceed to the next slide. So this is all about HDFS architecture. Sorry. Till now, we were talking like there is a master machine and there are slave machines. Let's talk about their technical Hadoop terminology. So this is a name node. This is nothing but my master machine only. This is a backup node. This is the backup of my master machine. In case if master is down, there must be someone who can take care of the responsibility, because there is only one master. So just like in school, we have vice principal who can take care of the responsibility in case principal is absent. Similarly, in case your master machine is down, the backup machine can help you. So apart from master machine and the backup machine, we are having 5 data nodes. Data nodes is nothing but the technical Hadoop term which is used for slave machines. So you can say that I'm having one master machine, one backup master machine, and 5 slave machines. So, and you can see one more thing, that master machine is giving instruction, or you can say it is controlling all the slave machines. So this was all about the architecture of Hadoop, that is master slave architecture. We have 7 machines in our cluster. Out of 7, one is master, one is backup master, and remaining 5 are my slave machines. So that was all about the architecture. Now let's talk about these colorful blocks. These are 3 and 5, 15 colorful blocks. Suppose that it was previously a very big file which could not be stored on a single machine. So what Hadoop did is, Hadoop has splitted that big file into smaller parts. So now instead of storing that file on a single machine, we can store these first 3 parts on first machine, next 3 parts on the next one, next 3 parts on the third one, like this one. So ultimately, we have distributed the storage. The file which was very big, we have splitted that and we have stored that file on multiple machines. Okay, there is one more thing which you might have noticed, that this orange block is available on the first slave machine, it's available on the second slave machine, as well as it is available on the third slave machine, this one. So what's the meaning of storing the data on multiple machines? As I explained you in the previous slides, that in case 1 or 2 machines are down, your Hadoop can still complete your job. So how is that possible? Because we have stored the data, duplicate data on multiple machines. That's why that is possible. You can say that if I want to access my orange block, I can access it from first machine. In case my first machine is down, I can access it from second machine, because second machine also contains my orange block. Similarly, if that is also down, I can access it from third one. So you may be thinking, if third machine will be down, then what will happen? In that case, we will not be able to access our data, because there is limit for each and everything. But we can configure that. If you need more than 3 copy of data on your Hadoop cluster, we can do that. If you say that no, I don't need 10 duplicate, 3 duplicate copy, I just need only 1, we can do that as well. So that is configurable. And when we will install Hadoop, I will explain like how we can configure the number of duplicate copy of the data which we are maintaining over the HDFS. So that was all about HDFS. So if you're having any doubt, please let me know. Otherwise, we can proceed to the next part, that is MapReduce. Yes. So MapReduce. Yeah, any doubt?
Yeah, I have one question here.
Yeah, please tell me.
How the master node knows that the data node one is down,
Okay. Yeah, that
needs to process the data, and second one?
yes, that is very good question. Let me tell you. Your data node keeps on sending a signal message every after 2 minutes to your master machine. So just by receiving that signal message, your master machine is keeping a list. It is maintaining a list which tells that this machine is live or this machine is dead. If in case it's not receiving the signal from a machine since long time, it will mark that machine as dead. And after that, whenever you are asking for some data, because as a user we need to interact with master machine only, so when you will ask for the data, it will try, it know that the first machine is dead, so it will not send the read request to the first machine. It knows that the same data is available on second machine, so it will redirect your request to the second machine. In case in its list second machine is also down, so it will redirect your request to the third one, like this. So the master machine does not have your data. You can see this one, these colorful blocks are not stored on master machine. Master machine is responsible for coordinating, controlling and managing all the things. So is that clear now?
Yeah, one more follow-up question
Yeah.
is that because since the data is spanned across three different machines,
Okay.
which one is chosen out of these three to be processed?
Okay.
Say, for example, all three are up and running, and I need some piece of data. Say, for example, orange block, I need to be processed. It will be processed on a mission 1 or mission 2 or mission 3.
Okay. First of all, your master machine contains all the metadata. Metadata means the data about data. It knows where your data is located and on which machine the duplicate data of some particular file is located. So it keeps all the information, like this is my original data and these are my two duplicate copy of that one. So first of all, whenever you want to try to access or process your data, it will try to access from the original machine. After that, if that is down, it can access from the second one or it can access from the third one. So it depends on your master machine, and as a user we never know from where it is accessing. When we will process the data, we will simply tell the file name, and internally automatically it will access from that machine, or if that is down, it will access from the another machine. In case every machine is down, your job will be failed, and you can go to the job details and you can find out why your job was failed. So once we will
Okay.
install Hadoop on our machine, I will provide you the steps to install Hadoop on your machine. After that, if you are having any doubt, we can look into that.
Okay.
Is that
Okay.
clear?
Yeah. Because if it is processed, so that means we have something to be configured, or it is automatically process orange block of data in emission 1, and master node knows that it's already been processed, so it's not going to touch the data in other two machines.
Okay, yeah.
That's what it is, or can we configure something there so that the primary, see three different copies, and the primary copy is mission 1, and
No, no, no.
master node always look mission 1 to be processed.
Let me explain you.
Yeah.
As a user,
Yeah, because
as a user, we are not bothered about that one. How many parts it has made out of my file? My file, as a user, I know that there was a file with some name. I know that name only. I don't know how many parts it has created. I don't know where it has stored my data on which machine, and how many copies it has created. Means how many copies we know, but on which machine it has created the copies, we don't know about that. So ultimately, as a user,
okay.
we just know the file name. When we will process the data, I will specify the file name. Behind that, it may be finding all the required smaller parts, and those may be stored on multiple machines. So it's duty of a master machine to take care of all those things. So I would suggest that when we will install Hadoop and when we will do the practice, this will be more clear to you.
Okay, yeah, I understand. It's clear now. So that you mean to say that the master mission itself takes care of
Yes. Yeah.
which mission the data should be processed,
Yes. Yes.
and
Definitely.
yeah. See, my worry here is that what happens if master data processes the same kind of data in two different machines? So
No,
that's
no,
what
no,
my
no.
worry was. So,
No, that is not possible because your master machine knows that that is original and those are duplicates. So it will start your query. Suppose you want to process some data, so it will start your processing on first slave machine. Suppose that in between the processing, your processing is not yet completed, and before completion, your machine went down just by any means. After that, it means that your master machine will not receive the signal from that machine. It means that after 2 minutes, your master machine will automatically know that okay, that machine is down and the processing is not yet completed. So what should I do now? From at least it will find out the data which was available on that machine, which is down now, the same data where it is available. So from its information, it will find out okay, the same data is also available on the second machine. So it will start the processing again on the second machine, so that your user will not have to you can say worry about that. Your processing will still be completed. It may take a little more time because the processing was failed on one machine and we need to reschedule it on another machine, but ultimately you will get your result. Is that clear now?
yeah, it's clear. So you mean to say that master mission is knowledgeable and it takes
Yes,
care of
yes.
everything, and
Yeah.
we
That's
don't need to
yes, yes.
manually configure anything.
Yeah, absolutely right.
Uh,
Because that is the responsibility of master machine. It does not contain your data. Let me tell you, your master machine does not contain your data. It does not execute any processing. So what it does, it is controlling the things. It is managing the things. It's coordinating between multiple slave machines. Slave machines are the machine which contains your data as well as which does your task. So just like as compared to school example, principal does not have any answer sheet. It means it does not have any data, and he also does not check any answer sheet. So he is giving instruction to the teacher. He is controlling the things. He is managing the things. Ultimately, the answer sheets are available with your teachers, and teachers are checking them.
yeah, got it. Clear.
Okay.
Thank you.
Okay, welcome.
Yeah.
So that was all about SDFS. Next, I was talking about MapReduce. So what is MapReduce? So MapReduce plays a key role in Hadoop framework because MapReduce is all about processing your data. In HDFS, we have talked about storage, but you know that storage is not a big deal. You can even attach some hard disk or some portable hard disk to your system. You can take care of storage. The main problem is with processing. When we want to process large amount of data, we need MapReduce because MapReduce is a programming model which help us to write programs, write Java programs, or you can say write applications with a specialty that can be executed on multiple machines, and ultimately we can rapidly process large amount of data. So now we'll talk more about the mapper and reducer separately. So before I explain the mapper and reducer, let me explain you in that school example context that will help you to understand in more easier way. So the principal had distributed the task of checking 1,000 answer sheet among uh, 10 teachers. It means that one teacher is responsible for checking 100 answer sheet only, and he will be preparing the result for 100 students. Similarly, the next teacher will do the same. The third teacher will be doing the same. Ultimately, at the end, I will be having 10 different results. The principal will say that, no, I don't need 10 different results. I have distributed among 10 teachers, that is a different thing, but I need only one result. So what should we do now? So principal will give instruction to one teacher that please collect the intermediate result, the smaller result from each teacher, consolidate that into a single unit, and then the final result you can hand over it to me. So the first activity, the first processing each teacher is doing, which is assigned by the principal, that processing is known as mapper. And the second activity, one teacher is consolidating the result by collecting the smaller result from each teacher. That activity is known as reducer. So that was all about the school example. Let me now explain you in the Hadoop context. Suppose there was a big complex processing and that was assigned to distributed among multiple machines. Now each machine is doing its own part, whatever is assigned by the master machine. That part, that processing is known as mapper. They will be completing their processing. They will be preparing some intermediate result, and after that, the reducer will be fetching the intermediate result from each machine and will be consolidating that result into a single unit. That will be your final output. So in a programming language context, or you can say in a definition type thing, mapper is a function that process input data from HDFS and generate intermediate output data. Here this output is not the final one. That's why I'm saying that this is an intermediate output. After that, reducer will be merging the intermediate data from all the mapper and generating the final output data. So this was all about MapReduce and mapper and reducer. If you are having any doubt, you can ask me. Otherwise, we can proceed to the next slide. So next we have is Hadoop cluster. As I explained you earlier, that Hadoop cluster is a set of multiple machines which are connected to each other. We may have multiple machines in our Hadoop cluster, but as far as the type of machine is concerned, we have only three type of machines in our cluster. First is name node, that is master machine. Second is a secondary name node, that is my backup master machine. And third one is data node, that is my slave machine. So in a particular Hadoop cluster, we have one name node, one secondary name node, and multiple data nodes. So this was about Hadoop cluster. Next we have is Hadoop processes. When the Hadoop is running on our system, it means that there are some processes, there are some services running on our system. So I will provide the step to install Hadoop on your system, because if I will show you some practical things on my machine through screen sharing, that will be practical for me. Those will not be practical for you. So I would be providing you the steps to install Hadoop on your system so that you can also do the practical things on your system. So once Hadoop will be installed on your system, there will be some processes running on your system. So let's see what are those processes and what are their responsibility. So the first process is name node. Name node, as discussed earlier, is a process which runs on master machine and it is responsible for your storage part. Next process we have is job tracker. It also runs on master machine, but it is responsible for your MapReduce, or you can say processing part. The next we have is data node, that runs on slave machine and it is responsible for your storage part. You can see the name also. Name node and data node, they are related to each other and both are working for your storage part. The only difference is name node is running on master machine and data node is the process which is running on slave machine. So whenever a file is coming for storage, your name node process will be analyzing the file. It will find out how many machines are available and what is the size of the file, and it will decide like how many parts it need to split into. So after that, it will be giving instruction to data node to store the file. So ultimately, name node and data node are working together to take care of your storage part. So similarly, we have another process, task tracker, which runs on slave machine and it is responsible for your MapReduce, or you can say your processing part. And as the name indicates, job tracker and task tracker are related to each other. The difference is job tracker is running on master machine and task tracker is running on slave machine. So similarly, if a big complex job or processing is coming to Hadoop, job tracker is the process which is analyzing the job first, and accordingly it will distribute among task tracker. So these are four processes which are running on your master machine and running on your slave machine. The same I have explained you, or you can say highlighted with the help of a diagram. So this is my central box, which is my master machine, on which name node process and job tracker process are running. These two are master process which are taking care of everything on your Hadoop. We do have the secondary name node, which is the backup of my master machine, and remaining all my slave machines. And on every slave machine, data node and task tracker, data node and task tracker, data node and task tracker is running. So this was all about the different services, different processes which are running on my master and slave machines.
All these processors are MapReduce processors or Java processors. So what are the processors
Okay.
like?
Okay. Let me tell you, MapReduce is not a process. MapReduce is a Java program which can be executed on your Hadoop cluster. You can say which can be executed on multiple machines. These are services which are responsible for something. Suppose name node is responsible for your storage part. Whenever a file is coming, we are splitting that file. We are storing on multiple machines. We are storing duplicate copy of the data. These activities are taken care by a service that is known as name node. Similarly, when a job is coming, the job is analyzed, that is distributed among multiple machines, and before completion, if some machine is down, we need to reschedule it on another machine. These type of activity are taken care by another service, another process you can say, that is job tracker. And all those activity are taken care by data node and task tracker on the slave machines. So these are the services which are, you can say, responsible for your two parts of Hadoop, that is storage and processing.
So you mean to say all these are Hadoop processors?
Yeah, definitely.
Hadoop daemons or something?
Yeah,
Because,
daemons, yes, you are absolutely right. Hadoop daemons are the correct term. I was using a generic term process so that everyone can understand. The correct term is Hadoop daemons only. These are Hadoop daemons which are running on your system.
Okay, so these are actually nothing to do with MapReduce.
No, it has nothing to do with MapReduce. MapReduce is a program which will be executing on this framework. These services will be responsible for running your MapReduce program.
Okay, got it.
Thank you.
Thank you.
So this was all about very details about the different services. Next we have is distinction. How a Hadoop framework is different from other frameworks. So first of all, it is simple. So as far as hardware is concerned, we don't need to purchase any special server or any special hardware. Just like in Oracle or MySQL, we need to purchase some special server. In Hadoop, any commodity hardware means any machine which you are having at your home, that may be your PC, that may be your laptop, that can be used as a machine in Hadoop. So that is quite simple. As far as software is concerned, that is free of cost available. You can simply go to Apache website. You can download it from there and you can use it for your own purpose or for enterprise purpose. Moreover, it allows user to write the MapReduce program, or you can say write the application which is capable of executing on multiple machines. Hence, you can handle a large amount of data. So that was all about simplicity. Next feature is reliability. As we are running Hadoop on commodity hardware, simple machines, our PC or laptops, it may be possible that sometimes our system may fail. But there is nothing to worry. As we have explained earlier, that if the processing is failed on one machine, your Hadoop will automatically detect that and it will reschedule that processing on any other available machine, which may contains your duplicate data. So ultimately, as a user, we need not to worry about that, and Hadoop can automatically handle such type of failures. So that was about reliability. We can fully rely upon Hadoop for taking care of such type of things. The last but not the least is scalable. We can increase or decrease the number of machines in a Hadoop cluster. If you think that your jobs are still taking time and you are using 10 machines, okay, you can increase the machines. Instead of 10, you can use 15 machines now. And the vice versa. If you think that 10 machines are not required, 10 machines are more than enough, your jobs are getting completed in less amount of time. In that case, you can even decrease the number of machines in your Hadoop cluster. So that was all about scalability, and with this slide we are done with the technical part, but we are still left with one thing, that is the most important thing, that is prerequisites. So what are the requirement, software and hardware requirement if we want to go for this Hadoop training? So the first is Linux based operating system. You may be joining this demo class from Windows, but let me tell you, Windows does not support your Hadoop. So in order to install Hadoop and to learn Hadoop, we need Unix based operating system, that is either macOS or Red Hat or Ubuntu. So in case you don't have any of the operating system, Ubuntu is the best option, and that's why I have highlighted Ubuntu in green. So let me tell you why Ubuntu is the best. First of all, this is an open source, free of cost available over the internet. Second is you don't need a bootable hard disk for a bootable disk to install Ubuntu. With the help of internet only and within 10 minutes, we can install Ubuntu on our system, and moreover, it will be installed as a dual boot. It means that your Windows will not be affected, that will be intact, and along with Windows, Ubuntu will be installed. So ultimately, there will be two operating system on your system. When you will reboot your system, it will ask for operating system selection. Either you can go with Windows or you can go with Ubuntu. So depending upon the requirement, if you are doing your personal stuff, you can go with Windows. If you are doing the practical things on Hadoop, you can go with Ubuntu. So that was the very first and most important requirement. The next is Java 1.6 or higher version is required. So that is not a big deal. That is free of cost available. You can download it and install it within 5-10 minutes on your system. Next thing we need is disk space. So we need disk space for SDFS part, your storage part, and we need RAM for your processing part. But we know that if someone is having PC or laptop, he will also have the hard disk and the processing RAM. So there is no issue with that. The next requirement is a cluster of computers is required for learning Hadoop. As per this diagram, you may think that we need 7 machines, 1 master, 1 backup master, and 5 slave machines. So that is not true. For learning purpose, we don't need 7 machines. We can even install Hadoop on single machine. So in that case, our own machine will be working as a master machine, as well as our own machine will be working as a slave machine. So you can say that all the master process, that is name node and job tracker, will be running on our own machine, as well as all the slave process, that is data node and task tracker, will be running on our own machine. So this was all about prerequisite, and with this slide I am done from my side. If you are having any doubt, you can ask me now.